All right, let's talk about what happens when two of the world's biggest threats run smack into each other. On one side, you have the sudden, massive power of a natural disaster, and on the other, you have the quiet, creeping crisis of superbugs.
So let's start with this number, 10 million. That is the number of people who are projected to die every single year from what's called antimicrobial resistance, or AMR, by the year 2050. I mean, to put that into perspective for you, that's more people than currently die from cancer. It's an absolutely staggering figure, and it points to this slow-motion global health crisis that's just getting worse and worse.
And this is a really great way to think about the two forces we're dealing with here. You've got the slow tsunami of AMR, which has been building up its power kind of silently for decades. And then you have the fast tsunami, an earthquake, a hurricane, a massive flood that just hits with almost no warning.
So the big question is, what happens when the chaos of a disaster creates the perfect storm for this silent pandemic to just explode? To really see how this works, let's dive into one specific kind of disaster.
We're going to zoom in on earthquakes. The research that's come out after major quakes gives us this disturbingly clear picture of how these two tsunamis make each other's destructive power so much worse.
It all kicks off with this chain reaction. The earthquake hits, causing a mass casualty event that just instantly swamps the healthcare system. Suddenly, doctors and nurses are working in these makeshift field hospitals where proper infection control is, a luxury they just don't have. This, of course, leads to a huge spike in wound infections. And in that kind of environment, multi-drug-resistant bacteria, they don't just survive, they absolutely thrive.
And this is not just theory. The reality is, it's pretty grim. After the 2023 Turkey-Syria earthquake, one study that looked at pediatric patients found that almost 74% of certain bacterial samples were what we call pan-drug, or extensively drug-resistant. That means they were resistant to almost all, and in some cases literally every single antibiotic we have in our arsenal.
So let's just take a quick step back and make sure we're all on the same page. What exactly is AMR? Well, think of it like evolution on hyperdrive. The microbes, bacteria, viruses, you name it, are exposed to our medicines. The strongest ones survive, they multiply, and they pass on their resistance. And pretty soon, a simple infection can become completely untreatable. That right there is the slow tsunami.
Now, disasters pour gasoline on this fire through two main pathways. The first one happens inside those overwhelmed clinics and hospitals. And the second one? It happens outside, in the environment itself.
Okay, so let's look at that clinical pathway. In the absolute chaos of a disaster, doctors often don't have the time or the labs to figure out exactly which bacteria is infecting a wound. So to save a life, they have to use broad-spectrum antibiotics. It's kind of their best guess that targets lots of different bacteria. And while that's totally necessary, it also puts this immense pressure on all the bacteria to evolve resistance. Then, in crowded shelters, those new superbugs can just spread like wildfire.
Now, the environmental pathway is just as alarming, especially when you're talking about floods and hurricanes. I want you to picture floodwaters as this giant toxic soup, just mixing together sewage, waste from hospitals, runoff from farms, all of it. This soup becomes a massive reservoir for what are called antibiotic resistance genes, which are basically the blueprints for building superbugs. And then, of course, people get exposed just by touching the water.
And again, this isn't just a what-if scenario. Studies of actual floodwaters confirm just how dangerous this is. After one major flood, a staggering 82% of the bacteria they found in the water were already resistant to at least one drug. The disaster literally seeded the entire area with resistance.
So look, the connection here is crystal clear. Researchers, humanitarian workers, the people on the ground, they know this is happening. Which just begs the question, why isn't this a top priority in every disaster response plan? Why is this so hard to get a handle on?
Well, the answer really boils down to something pretty stark: a brutal battle of priorities. The experts in humanitarian aid know this is a massive threat, but when a disaster actually strikes, they are forced to make some truly impossible choices.
This quote from an expert really just says it all. When people are trapped under rubble or they don't have access to clean water, the immediate life or death needs have to come first. AMR is seen as this longer-term problem. It's a marathon you have to worry about after you've already finished the desperate sprint for survival.
And that raises the most critical question of all, doesn't it? If the middle of a crisis is the absolute wrong time to try and focus on AMR, then how do we prepare before the disaster even strikes? How do we build systems that can actually stand up to both of these threats at the same time?
The answer, according to the experts, lies in this concept called One Health. And it's actually a pretty simple but incredibly powerful idea. You can't protect human health by itself. You have to consider the health of animals and the environment at the same time because it's all deeply, deeply connected. A disaster doesn't just hurt people. It shatters the whole ecosystem, and that creates a perfect bridge for these microbes to cross.
So when you start looking at the problem through that One Health lens, a clear, two-part solution starts to take shape. This approach has two layers. The first is the foundation. These are the absolute non-negotiables. We're talking about robust systems for water, sanitation, and hygiene, that's called WASH, and basic infection prevention and control, or IPC. These things have to be part of everyday life, not just something we think about during a disaster. Then, the second layer is the long game, investing in strong, prepared healthcare systems that don't just collapse the second a crisis hits. You see, the foundation keeps you safer during the disaster, but the long game makes the disaster less devastating in the first place.
All of which leaves us with this final thought to chew on. We spend so much time planning for the things we can see, the shaking ground, the rising waters, but are our plans really ready for the invisible enemy that comes right after? Because in our world today, the next big disaster might not be the one we can see coming.